Hello everybody, here I am going to define charge because I have noticed that there are many students of intermediate level they don't know about actual concept of charge. They only know the box definitions. Therefore, here at this time I define charge. I'm going to define charge. In charge is a property that tells us about the deficiency or the excess of electrons in a body. If a body has a charge, then we can say that this property gives us information about the deficiency or the excess of electrons in their body. We would explain that what mean by positive charge, what mean by negative charge. Is there excess of electron or deficiency of electron? We will discuss all these things. Naturally, atoms are neutral. Number of positive charges, protons, at the center, at nucleus, in the nucleus, equal to the number of negative charges, electrons. Electrons are revolving around the nucleus. In classical point of view, and protons, the positive charges, are present at the center. Therefore, we are talking about the negative charges, about the electrons, its deficiency or the excess of electrons, because we can only remove electrons or add electrons to an atom. Hence, we can increase or decrease the number of electrons. And the positive charges that are existed at the center, it is difficult to remove or increase or decrease the number of their positive charges. Therefore, we say that charge is a property that tells about the deficiency or the excess of electrons in a body. This is not a natural property. We can create this property, we can give this property to anybody if we increase or decrease the number of electrons. If we consider sodium here, the number of positive charges in a sodium, which are 11, are equal to the number of positive charges that are 11 at the center. The number of negative charges equal to number of positive charges, protons. Therefore, sodium is neutral, and similarly in chlorine, the number of negative charges, electrons, equal to the number of positive charges, protons, existed at the center. Hence, the total charge is 0. 11 proton plus 11 electron equal to 0. And similarly for chlorine, total charge equal to 0 because there are 17 protons, 17 positive charges and 17 equal negative charges. Therefore total charge would be 0. Now an atom adopts positive charges if it loses an electron, and there would be deficiency of electron, like in chemistry we discussed that sodium got positive charges by losing one electron. If an atom got an electron, then a negative charge would be created upon it due to increasement in the number of electrons. Like in chemistry, chlorine got negative charge by getting an electron. Like sodium has one electron at its last shell orbit, and chlorine has 7 electrons. There is a deficiency of electrons. Well, chlorine requires 1 electron and sodium has 1 electron. Now if sodium will react with chlorine, it would give its 1 electron to chlorine. Hence there will be deficiency of electrons in sodium. Now there are 10 electrons, and in chlorine now there are 18 electrons and 17 protons, and at sodium there are 10 electrons and 11 protons. So here we can estimate the value of charge, that at sodium 11 proton 10 electron, therefore the total charge would not be equal to 0, and hence the total charge would be positive. And chlorine 17 proton and 18 electrons, so hence the total charge would not be equal to 0 and it would have negative charge. Hence we can create a charge on a body by transferring an electron from one body to another. Therefore we say that charge cannot be created nor destroyed. We do not create any charge, just transfer electron from one body to another. This is law of conservation of charge, because charge cannot be created. This is not like such a new thing that we are going to recreate. Just it can be produced by transferring one electron or too many from one body to another body. Just therefore there would be imbalance in the number of positive charges and positive charges and negative charges, and due to this reason there would be a charge creation. Charge is a quantized quantity. It does not exist in fractions. Like a body has 1/2 charge, its basic unit charge has its basic unit is E, and the minimum charge that can have body is E. E is the charge of electron or proton. Now the electric charge, there are 3 intrinsic properties for elementary particles: mass, angular momentum, electric charge. Electric charge is our concern. And the electric charge in any elementary particle can take only one of 3 values, like the charge of proton, which is 1.6 10 to the power minus 19 coulomb, or electric charge of the neutron, which is 0, and electric charge of electron, which is minus, equal to the charge of proton but with negative sign. Hence any body can have the value of charge, magnitude of charge, that would be multiple are equal to or multiple of the charge of electron or the charge of proton. Therefore, we can say that charge is a quantized quantity. Its basic unit is E. E is the charge of electron proton. Hence, E, the minimum charge that can have body. There is no body in the universe that can have minimum charge than electron, the whole charge. We are not talking about the quarks or others small particles, that is quantum mechanics, but we will keep our concern up to our basic elementary particles, that is electron, protons. Hence, the electron is a body, is a particle that has a minimum charge, that is E, and other bodies in the universe then can have equal to the charge value equal to the charge of electron or proton, or the multiple of this, 2e, 3e, 2 times the charge of electron or proton, or 3 times is similarly, but cannot have in charge in fraction like 1/2 the charge of electron or proton, or 2/2 something like this, because charge is quantized. It does not exist in fractions. Like charges repel each other. If there are two like charges, like positive positive, they would repel each other, and if there are negative negative charges, they would also repel each other. But opposite charges attract each other. Charges, a body can have only two states. The body can have only two states. It may be at rest, it may be in motion. It may be at rest, it may be in motion. And similarly, charges are also body. Therefore, charges may be at rest or in motion. While studying about the charges, when the charges are at rest, then at that time it's study called electrostatic. Static means at rest. Hence, electrostatic is a branch of physics in which we study about charges while the charges are at rest. And the branch of physics in which we study about charges while the charges are in motion is called electrodynamics. Dynamics means motion. The effects produced by charges while at rest are totally different when the charges are in motion. Therefore, the laws which are applicable and the theories, these all things would be different for both states, like Coulomb law. Coulomb law is only for static charges, that is for electrostatic or Gauss laws. But for charges which are in motion, Ampere's law is applicable. Ampere's law is not applicable to static charges. Therefore, the theories, the laws, everything's effects would be different for static charges and for the charges which are in motion. These are two different fields. Thank you. If you have any question, any misconception, then you can send me You can contact me for feedback also with through my email address. You can see it at the end of the screen, orif_foreign_code@outlook.com, and please like us on Facebook with this link. Thank you.